Hello, myself Muhammad Imran Seke. I am an electronics and communication engineer from the National Institute of Engineering, Mysore. So today my topic of presentation is robots and robotics. Yes, a robot is a virtual reality machine or an electro-mechanical machine which having mechanical parts along with electronic circuitries as well as computation blocks by computer science. So these robots are used to perform specific tasks, designed to perform specific tasks in a semi-autonomous way or in autonomous ways. So as we look into the history of robotics, so the robotics term was coined by a Czech novelist Karl Popper in his play Rossumann's Universal Robot, and later on the robotics were used by science fiction novelist Sir Isaac Asimov. Then as we look into the history, in 1954 first industrial robot was designed. Its name is Unimate. So it's also called universal automation and used for handling TV tubes. Next one is in 1978 a Puma, programmable universal machine for assembly. So this one is a programmed machine in which a computation blocks are used. And in 1980s, by looking to the growth of robotic industry, most of the institutions offer courses on robotics, and they give and they provide education to the students in the field of robotics. And in 1995 to present, it marks a beginning of locomotion robots, such as mobile robots, and researchers came such as so many companies involved in this robotics. And next, this marks a social impact in the human society. So roughly half of the robots are in Asia and 32% in Europe, 16% in North America, and world's 30% of the most of the robots in Japan. So next come to the technological trends which are seeing in robotics is one is evolutionary robotics. So in evolutionary robotic concept, here it uses same as evolution concept of a living organism in which different robots are going for series of tests. The robot which performs very well, they are considered to be evolution robot. And next one is a developmental robotics. So in a developmental robotic concept, to a single cell of robot, here the robotic arm or a leg or intelligence is going the enhancement in these parameters. So that considered to be a developmental robot. And next we look into we coming to the main concept here. So here I divided into three parts. One is general concept of robots and robotics. Next one is an industrial robot, and lastly humanoid robot. So first we look up in first chart. I presented general concept of robots and robotics. First part is a power source. So the main power source. So to derive any machine we need a power source. Here robot to need a power source. First is the electrical power which derived from batteries as well as electrical connections too. The batteries which we use is lead acid batteries. So to ensure safety, cycle lifetime as well as weight. So here weight the weight as weight is reduced, so much the lightweight of the robot weight. Next, in second line of source we having pneumatic source as well as hydraulic source. So these source having high pressure gases as well as lubricants we use for up and down movements or side to side movements as braking purposes. Next one is a flying wheel energy storage. So this flying wheel energy storage having rotational wheel. So it ensures the rotational movement to the robot. Next, the power source which having potential energy. This potential energy is converted to kinetic energy by using actuations. So these actuations are also called actuators. One is electrical motors. So these electrical motors, they take potential source as electrical voltage that derived from a battery as well as electrical connection. Next one is linear actuators. So these linear actuators take source from pneumatic source as well as hydraulic source. Next, in series elastic actuators, they are having compressed spring for the mechanism of a robotic leg. And in electroactive polymer, so this electroactive polymer the same as human muscles. So upon introduction of small electrical signal to these electroactive polymers, they work as a human muscles. They contract and expand. Next is piezo motors. So by applying slight pressure to these motors, the crystal inside that motor it generates electricity in an oscillating form. So these are the actuators we use here. And next come to the sensors. Generally sensor marks the presence of robot with the environment. One is it gives configuration as well as environmental presence. Environment is analogous in nature, so analogous type of signals which are going to convert inside to electrical one. So that is going to, one is carried by vision sensors. Here robot can vision give two-dimensional image as well as three-dimensional images, and this force sensor marks for forceful of part fitting and insertion any objects, as well as in industrial robots as well as in humanoid robots, to pick up an object and piercing or putting somewhere else. And next in proximity sensor. So these proximity sensor ensures the distance between a robot to that object. So here it measures the distance by using ultrasonic sonars as well as infrared ray detectors. Next come to the tilt sensor. So tilt sensor ensures the balance to the robot. So these are the few sensors which extensively we use. And next come to the manipulation. So in the manipulation, it's generally a robotic arm. So as a human arm, so manipulation performs the same work. It consists of two parts. One is arm and hand. So generally arm called a manipulator, and this hand called an end effector. End effector is always going to replace with mechanical gripper or vacuum cups or even fingers or robotic fingers. So next comes the controller. In a controller, for a controlling mechanism we always use three types. One is without feedback controlling mechanism, next with feedback, and last one is controlled feedback mechanism. Here controlling is generally in three steps. One, information from the sensor that goes for perception, and next estimation. Whatever the information comes from the sensor, that is converted to electrical signal. Here it is calculation of that in processing block. And next comes the task, means after calculating, the task is going to perform with the actuators. So the signal is used to the actuator to perform the task. Generally robots having manual control, a human can control a robot. And next, semi-autonomous control means for a certain time duration, robots having control for its own. But in last one is autonomous control. Once you switching on the robot having control mechanism of its own. So this corresponds to autonomous control of the robot. Next, look onto the storage hardware. So this storage hardware is always linked with the controller. So it's having solid state circuitries as well as solid state interfacing devices too. So the memory block consists of control programs and programmable logic controller, which stores the information fed from the sensor. It marks some values. Next, in computation hardware, we having microprocessor as well as microcontroller with embedded system designs. So these linked with the interfacing hardware. So these hardware linked with the sensors as well as displaying purpose. So such as digital converters, analog to digital converters, and op-amps for amplification of the signals. So this marks the storage hardware. Next come to the locomotion part. After the 1980s only we provide locomotion to the robots. So first type of locomotion is rolling. Here robot having rotation mechanism, in which a two-wheeling balancing robot. In between the two wheels of balancing robot there is a gyrometer which calculates the falling of a robot due to gravity. Once it measures in millisecond and generate counter rotation to the robot for against the falling. Next, in one wheel balancing, so it uses the same concept of two wheel balancing, but here one wheel balancing is the rotor is of a spherical shape, that of a human diameter size. Next, in four wheel type, here these four wheels are controlled by a relay which having motors, and relay signals come from the microprocessor or a microcontrollers. So the expansion of four wheel concept to the six wheels as well as tracked robot that were essentially used in muddy surface or uneven surfaces. Next type of concept is walking applied to a robot. So this marks the beginning of humanoid robots, in which a zero movement point technique. So in this zero movement point technique, a normal drawn to the robot. From that normal, it measures the center of gravity. Once the shift in a center of gravity in the trunk region, again the robot generate counterbalancing force for that center of gravity and balance the robot. Next one is a hopping. Generally in some robots they used to hop, and dynamic balancing So this dynamic balancing concept is to stabilize the stance as well as walking movement by using microprocessor that fixed in a robotic knee. Next, in some robot having flying concept, one is autopilot concept in avionics, a plane which having this autopilot concept which can use for taking off, landing as well as controlling the plane without a pilot. Next, in unmanned aerial vehicles. So these are all small robotic vehicles which use for flying purposes. They extensively used in military purposes. Next one is the environment interaction in navigation. Generally, some robots were designed to perform action in controlled environment. But even if we want to perform that robot to an unknown environment, we use a GPS as well as radar technology. So here, by using GPS and radar, it marks the position of the robot in the environment, and next it used to detect the unknown obstacle in between in the way to the robot. And LiDAR as well as video camera. So LiDAR, it used to sense the light, colors of light, and video camera and internal guidance system by constantly feedback given from these sensors. So the robot internal guidance system which guides the robot in a desired way. So this is about the environment interaction and navigation. Next come to the concept of physical motion. So that makes dynamics and kinematics. So here we use direct dynamics as well as inverse dynamics, and direct kinematics and inverse kinematics. In direct kinematics and inverse kinematics, here measuring the joint values as well as end effector position and velocity and acceleration of the movement of an arm or a leg. So by knowing those values, and in direct dynamics and inverse dynamics, we are measuring the force as well as acceleration which are going to work on end effector values. So this ensures the avoid of collisions as well as singularity in a robot. So this marks the concept base for robots and robotic technologies. And next, look onto the modern type of robots which are generally working is, one is mobile robot. So this is one of the example of NASA's Mars rover. So this robot is designed to perform, to move in uneven surfaces and to constantly give signals back to the Earth, and information, whatever the studied information on Mars, sent back to the Earth. And next one is an industrial robot. So this robot is also called a manipulator, which having very good degree of freedom, and it can move in various axes. So this robot is used to perform pick up an object and placing to another side, and assembly type of requirements. Next is a service robot. Service robot, some human tasks, garbage collecting or sweeping or cleaning something. So we are taking use of robotics. We use these service robots. And next one is a military robot concept. So most of the military robots are in US Army. So one type of example is Predator. It is an unmanned aerial vehicle from a controlling station. This vehicle can be make use to fly and attack on enemy. Next one is a tracked robot which fixed with ammunitions. So this robot can use to for the same attacking purpose in a land on land. Next one is medical robot. Medical robot having various types. One is surgery robot and patient taking care of robot. So it performs surgery well with very sophisticated manner, and a healthcare robot which ensures the patient's data. And next one, nano robot. So these nano robots are in range of 10 to the power -9 meters. So these robots used to study the internal structure of organisms or any body parts and used to kill cancer cells too. And humanoid robot. So here a human action is going to replicate into robotics. So these designs are carried by Honda's ASIMO humanoid robot and such as Sony's QREM. So HRP robots. So this marks the later generation. It is estimated that in 2030 one day, human having personal computers. Likewise, we have humanoid robots with us. So this is about the first general concept of robot and robotics, as well as types of robot which we use here. And next we are moving to industrial robotics. Yes, next is the industrial robot technology. This is the second part of our presentation. In this, the definition of the industrial robot is very much simpler, and it is applicable to robotics too. Here, machine tools is going to work with the computer applications. Here, most of the advanced computer applications which are going to handle machine tools, and here computer applications work as a controlling part for these machine tools. And the main concepts for the industrial robot technologies are machine design, control theory, microelectronics, computer programming, artificial intelligence, human factors, and the production theory. So as we've seen, these are the knowledge base for industrial robot technology. And the general characteristics of industrial robot technologies are: first, it's having a specialized machine tool which is going to work and with having a very good degree of flexibility. And that degree of flexibility and that machine tool we called as a mechanical arm. And to that mechanical arm is going to interface with the work environment. And the normal terminologies we are going to use in industrial robot technologies are work envelope, payload, velocity, cycle, accuracy, repeatability, as well as resolution and size. Here, work envelope means an industrial robot having its own boundary envelope, imaginary points. So within these points, the manipulator takes his arm depending upon the required axis. And next, the payload is the amount of weight which is going to take by a manipulator to lift products. So this payload is directly related to the power source. And the velocity, so here the motion started from series of joints. So the amount of speed which is going to carry by this manipulator, it gives the velocity of the machine. And next, the cycle. So in this cycle, it's starting from the one joint is going to link with another joint till to the end effector. The cycle means a series of motion will repeat. So that we call a one cycle of a manipulator. And here, often and often, repeatedly, for a given amount of time, the cycle is going to repeat, is called accuracy. And in a repeatability, so in a repeatability, for a one single cycle and for another cycle, the repetition is going to be carried out. So for that, the manipulator works, and that's called a repeatability. And resolution, if there is any small change in a manipulator function, that brought to a controller. So that's use the resolution of a manipulator. And the size of an industrial robots varies, and as well as size and resolution also varies. So this is about the general characteristics of an industrial robot technology. And as we see, the basic components which we are going to use in industrial robot technologies are manipulator, end effector, power supply, and a controller. Here manipulator work as a robotic arm, as well as its arm function is like a human. And end effector is an end gripping tool. This gripping tool is a mounting point for various gripping tools. And power supply, so here the various concepts in power supply we will tell later. And the main function of the power supply is to provide and regulate in a system. And controller, this is a heart of a mechanism which is going to control the whole operation. So this is the block diagram of basic components or a basic robotic module, in which a controller, manipulator, end effector, and a power supply. So controller linked with the manipulator and from the end effector. Here a feedback from a controller as well as feedback from an end effector, and controlling signal, controlling line to end effector as well as to the manipulator. As taking from external feedback and giving external commands, the controller starts its action from a power supply. So this is a brief overview about the components of a industrial robotic module. And next we look onto the manipulator. Its manipulator motion similar to human arm, and it has to do required amount of work which we desired. So its movement is same like a arm and body, as like arm and a hand. So it's having a motion of wrist and wrist motions. So first, motions of series of joints that connected in a manipulator, and next at the end a wrist motion. From that it's linked to a end effector. So here we giving a degree of freedom. So degree of freedom means, so manipulator have to move in a particular axis. That single axis corresponds to 1 degree of freedom. For a better manipulator action, so an industrial robot having a 4 to 6 degree of freedom. And the wrist motion corresponds to various actions such as rotatory, side to side, and up and down motion. So here a roll is a rotatory and performed such as a screwing operation or drilling operations. So that corresponds to x-axis, and a yaw side to side motion. So this picking an object, putting to another side. So this corresponds to y-axis motion, and a pitch, this corresponds to up and down operation. So that corresponds to x-axis, z-axis motion. So this is about the manipulator, and next we see the end effector. So here end effector is not actually the part of a manipulator, but we are going to fix this to a manipulator. Here it acts like a hand that perform open and close operation. So we are going to use a tool mounting point here that equipped with grippers, so that constitute fingers to holding an object and pick up it, placing to another side, or a vacuum cups as well as to pick up an object, and a spray gun for a painting purpose, and a spot and arc welding tool. So they perform welding operations as well as drilling operations too. So here in an end effector we use a tool center point. This tool center point is the origin of a coordinate system of this manipulator. From this point the axis point is going to be moved. So as you see, this end effector is a custom made. Depending upon the customer requirement, we are going to order for an end effector. So as we look onto the power supply, here power supply mainly used to provide energy as well as to regulate too. So in this industrial robotic technology, we are going to use 3 types of power supply. One is electrical, so that is very common and extensively used. Here we are going to connect it from wires. It is not in some cases we use battery power, and in most of the cases we are going to use wired power, and a pneumatic source. So this is the second most type of a source we are going to use in industrial robot technology. This uses a compressed gases, and a hydraulic source. This uses lubricants such as oils for doing pressure operations. So as like pressure pressing, those kind of things, we are going to use this pneumatic as well as hydraulic power source. And this power source is directly related to payload. So here the amount of manipulator which is going to lift a weight, so that is directly related with the power supply. So next we move on to the controller. Here in a controller, the first task of control is to initialize as well as terminate and coordinate the motions in a sequence way. So that is the one function of a controller. Here we are going to use, generally we are going to use 3 types of controller in industrial robotic technology, that is non-servo, servo and servo control. In a non-servo type, it is an open loop, so there is no feedback in this system, and in servo type it's a closed loop. After getting an output we get a feedback, and in servo control we are going to get constant feedback. So depending upon the requirement of work, we are going to use the control system in a controller, and here the heart of a controller is a microprocessor or a microcontroller or an embedded system which we are going to use along with a solid state memory. So as we see, this is a robotic controller computer. Here we are going to use a microprocessor as well as microcontroller. So this linked with a solid state memory that will be taken as a programmable logic controller. So here it shows the state of a controller, and from this one to the interface device. So from here it's going to work with the external environment. So from input and output section, whatever the commands are, from the information from the sensors which are going to fed to the computer controller. From this it gives its state. Depending upon that state, next signal commands goes to interface to perform a work. So this is about the block diagram of a controller. Here we use a cooling system to dissipate heat, and a system power converter for this controller block. So this is a controlling mechanism, and next we go on look into the robot configuration. In the configuration, it's depend upon purely the work environment of a robot, in which desired direction we are going to move the manipulators. So it's having a rectangular type. So in a rectangular manner, manipulator performs his work, as well as in cylindrical, spherical shape, and jointed arms. So there is one more type, that is SCARA, Selective Compliances Assembly Robot Arm. Here, depending, it's all about custom made. Depending upon their requirement, the assembly requirements will be done. So next concept is a robot selection. As we see, these are the basic concepts we are using in industrial robot technology. If a customer needs a specific robot for a specific operation, so he had to morely concern about the technical issues as well as non-technical issues for selecting a robot. So in this technical issues, first, what type of robot they are going to select. So that is non-servo, servo or servo control type, and the selecting a work envelope as well as robotic configuration, in which configuration they want to work. So payload, the amount of weight the robot is going to lift. So next, the cycle time, in what cycle time they want to perform the task. So repeatability as well as power drive, and so they are going to work on which type of power drive. So these things will come in a technical issues. And next we are look to in non-technical issues. First thing, cost and benefits, and next commonality and of equipment. So which are some of the equipments which are very much common, and selecting those things. Training and maintenance. Yeah, this is the main concern about this industrial robot technology, in which once getting a module, so we have to well learn about this training and maintenance part of the system, and service as well as safety precautions. If any damage or anything wrong will happen, how to shut down the system suddenly. So these are the non-technical issues we are going to keep in mind. And next, as we see the robotic generation, so generation in an industrial robot, in first generation we just have a pick and place robots. As I told earlier, as we told before, that a Unimate was used first robot, that comes in this category. And in second generation we use a hardware controller and first programmable unit by using microelectronics. So that use as a microprocessor or a microcontroller came in the use. And in third generation we are going much more advanced, like programmable logic controller that used to store the sequential logics of this controller, and a microprocessor based controller. So next, in fourth generation we went beyond PLC, we uses microcomputer starts control. So this takes the embedded system part. So the whole embedded system is going to work with the industrial robot technology. And in fifth generation we use artificial intelligence. So this corresponds with artificial neural network. So here it performs the operation with similar, it uses the intelligence of a humans, so to perform a very good operation in an industrial robot technology. So next, there are now in present days there are a lot of generations which came. So we are looking for fifth, sixth generation. We are going to build a robot, industrial robot, to like in a human way. So next, there are some, here I mentioned some of the models of phonic models of an industrial robot. So first one is R2000IB. So here I stands for integrated vision. So in this, so this is one of the manipulator which having a 6-axis heavy payload high performance robot. So this is very much ideal for spot welding as well as general assembly, material handling, and part transfer, material remover, and this is very much useful in assembly line. And next we look on to the paint robot. So this is P50IB. So which is a paint robot, and it is conventional for electrostatic spraying gun, and it's having a multi-gun configuration. So depending upon the type of requirement we can use to paint the objects, as well as this can be very much extensively used in automobiles. And next we will look to M710IC. So this is having a 6-axis medium to high payload. So solution for material handling, part transfer, assembly, packing and dispensing. And next is 200 IP, which having a 6 degree of freedom, in solution for subcompact robot welding and nut running, vehicle lift and locate, as well as to dispense. So these are the few examples of industrial robots, and next we are going to see about a humanoid robot. As I told earlier, most of the industrial robots, they are immobile in nature. They are just fixed on a ground or on a ceiling or on a roof. So, but they have very good degree of flexibility compared to other robots. In later advancement in robotic technology, so here next one is a mobile robot. So I selected a humanoid robot. So in this humanoid robot, we are going to build a robot which is exactly like a human. We are going to, even though we are mimicking most of the human actions to that robot. So as we see, before building a humanoid robot, Isaac Asimov, he is a science fiction author. He proposed laws for a humanoid robot. So it was only 3 laws. Later it added another law, that is law 0. So the law says a robot may not injure a humanity or through inaction allows humanity to come to harm. So first law says a robot cannot injure a humanity, but a human can injure a robot. And in law 1, a robot may not injure a human being or through inaction allow a human being come to harm unless this would violate a higher order law. So here he mentioned a higher order law. So this law says a robot may not injure a human being or through inaction, but it allows a human being to come to harm. So if a human want to harm a robot, there should be a criteria. That criteria is if a robot violates a higher order law, at that time a human can destruct a robot. And in law 2, a robot must obey orders given to it by human beings except where such orders would conflict with a higher order law. So second law says whatever the orders given by a human being, the robot must obey. But some orders it should not obey that conflict with a higher order law. And in third law, a robot must protect its own existence as long as such protection does not conflict with a higher order law. So here a robot having its own protection. So till that it can protect its own existence in the limit of higher order law. So these are the laws, and keeping these laws, I am going to explain Honda's humanoid robot. So I took only an example of Honda's humanoid robot, but in later views, in broad view, there are most of the companies as well as Sony, Motorola, as well as Kawasaki, they also developed their own humanoid models. So this ASIMO is very much like human in nature. So I selected this. So Honda is very much, Honda we know, they are designing most of the vehicles, two-wheelers, cars. So they take a new step in developing a robot which having a legs. Yes. So it uses a concept like advanced step in innovative mobility. So first they want to create a two-legged humanoid, and next the vision is that robot is going to live in harmony with the peoples and to help the peoples in their daily life. So this is about their concept and vision of creating this ASIMO. And as we see to the history of Honda's humanoid robots, first they started since from 1986. The first prototype was E0. Its walking speed is 5 to 20 seconds per step, and the speed is 0.05 km per hour. So from 1987 to 1991, they later stepping into more advanced type E1, E2 and E3, in which walking speed increases to 0.25 km per hour, and in E2 they developed the new technology with dynamic walking, which having a speed of 1.2 km per hour, and in E3 they increases the thigh length, so from that it increases speed to 3 km per hour. So later on in 1991 to 1993 they started with E4, E5 and E6. So it's having a quick human step up to a speed of 4.7 km per hour, and in E5 posture control and walks on a slopes too. So here in advancement is the robot is well posture controlled and it can easily walk on slopes too. And in E6 it is autonomous control of balance. So in 1992 to 1997 they started developing a new prototypes in which P1 they giving an upper body as well as arm to the robot that can operate as switches as well as pickups and pickuping objects, etc. So in E2 they have the robot having a plastic skin as well as wireless realistic movement. So by watching to the demo of this P2, people were shunned by its actions, and in E3 it's completely independent, smaller and lighter. So here the robot's much more compatible. So next we look in 2000 to 2005. The first very good humanoid robot coming to market is ASIMO version 1. So it is lighter, smaller, more flexible and more human-like. So it's having a very good feature like predict movement control. If any object, if any persons come in front of it, so it can predict that in which direction that person is going to walk further. So next, in 2005 to current, the latest version of ASIMO is ASIMO V2. So it can run 6 km per hour and it can turn while running. So it's having a advanced feature like it can do the receptionist duties, and it can hold your hand, it can take you for a walk too. So this is the ASIMO's V2 version, and here I'm going to mention ASIMO V1, its specification as well as its intelligence part. So its specification is ASIMO V1 is its height is 1200 millimeter and its width 450 millimeters, and from side view its width is 450 millimeters. So specification is its weight 52 kgs and walking speed is 0 to 1.6 km per hour, and walking cycle it's having an adjustable cycle. So it can use straight adjustable part also, and grasping force 0.5 kg per hand. So it can grasp objects easily with having this much of force. The actuators which you are using here is servo motor plus harmonic speed reducer plus a driver unit too. So by using these actuator blocks, it having a very good speed in walking. So the control unit which you are going to use is walking or operating control unit that having a wireless transmission unit. So that is linked with workstation, and a sensors foot having a sensor to balance, that is a 6-axis foot area sensor, and a torso which uses a gyroscope plus acceleration sensor. So this used to detect the gravity of falling, and depending upon that gravity of falling it can increase the acceleration to counterbalance the force. And in power section we use a 38.4 volts and 10 amperes per Henry voltage supply. So operating selection, workstation and portable controller. So this is about the general specification of this robot, and as we see the walking technologies which you use in this ASIMO is it's having a smoother and more stable walking, and it's having its intelligence walking technology. So in the legs only we are going to use microprocessors to map the walking pattern of this ASIMO, and from that mapping again the signal generates the same commands to the legs to walk in such a way, so that it's having a balanced stance and creating prediction movement control. So the while walking also it can predict in which way, if any person or any object is there, if a person will come in front of a ASIMO and it's by walking, so it can predict in which direction the person will go, and that will helpful for this ASIMO to change the direction. So here it uses a zero moment point which having a center normal point that is very much centered to the robot, that will correspond to a center of gravity. If any shifts, so according to that shift it accelerates the center of gravity and nullifies the effect and performs its walking action. So this makes the complete balance while walking of this robot. So here arms. So arms are very much controlled by in workstation. Arms having a very good degree of flexibility. So these arms can use in grasping as well as waving, walking and saying goodbye, and even for giving thanks, shake hands and responding to. So arms having a very good operating range and improves on operability. So this is about the arms, and we look into the intelligence of this ASIMO is it can recognition of a moving object. So as you see, the sensor, the vision sensor, it can have a 2D as well as 3D vision sensor with advanced image processing. And next, recognition of a posture and gestures. So it can recognize a person in what way he is, whether if a person is standing or sitting, it can recognize and get the information. And as well as gestures too. If a human points something into some direction, ASIMO can recognize that gesture and move to that direction. So second one is environment recognition. It's having a very good environment recognition capability by having a very good radar system as well as lidar too, so that used to detect light and distinguishing sounds. So the sound processing signal of the ASIMO is very good. It can distinguish various sounds as well as a human, different sounds from a different human, they can recognize, I can detect too. And having a very good face recognition by having a very good video sensors of 3D. So it can as well as by using these sensors, it can detect emotions too. So this is about the intelligence we use in a human ASIMO humanoid. And next we look into the advanced feature of grasp planning for a humanoid hand. So it's having a multi-finger hand attached to robotic arm. So a robotic arm, even a multi-finger hand to having a very good degree of flexibility, degree of freedom. So it measures object position. First the hand measures the object position and by using vision sensor, and then it plans for a body motions. So in the planning it prefers a fast algorithm for a plan and calculate the grasp planner to do the task. So this is about the grasp planning for a humanoid hand. As I said, the speech recognition, robotic voice and gestures and facial expression. So these are the very much new technologies, new trends in ASIMO humanoid. But there are so many things on the way to develop these things, and even ASIMO can generate his own robotic sound. So this is about the humanoid robot. And next about a general overview. So as I mentioned in 3 parts, general concepts of robotics, industrial robots and a humanoid robot. So this is a general description. If you are looking for designing a robot, so you must have to know for what purpose you are going to design a robot. Depending upon that purpose, you are going to select a sensor for that robot. And upon that selection, sensor selections, a controller is must to control a robot by using embedded C or by using very good programming. We are going to interact with a microprocessor or a microcontroller. With having a very good interfacing devices, you are going to communicate with a robot. So this is a generality of robots and robotics. Okay, this is it. Thank you very much.